Hello and welcome to Train Signal. This is video number 8, Administering Linux, Part 2. Part of Fast Track CBT Video, Linux Networking and Administration. Let's take a look at our table of contents. So in this video we're going to talk about managing and configuring print jobs and queues, using remote management software for Linux. We're going to configure and manage NIS with YP commands, and create and modify basic shell scripts. So let's start off with managing and configuring print jobs and queues. So Linux Plus Objective 2.16 says that you should be able to manage print jobs and print queues. For example, they say LPD, LPRM, LPQ, and CUPS. They also say in Objective 3.8 that you should be able to configure Linux printing, for example CUPS, BSD, LPD, and Samba. And finally in Objective 3.9 they say you should be able to apply basic printer permissions. So let's learn about how to do all these things. By starting off here. Most Linux systems have two printing systems. There's the BSD line printer daemon, or LPD, and there's the common Unix printing system, called CUPS. Many commands between these systems are similar, but not always the same. CUPS is enabled by default in Fedora Core 5. CUPS is the newer version of Linux or Unix printing, and they're trying to get CUPS to replace all the other printing methods. But so many of those printing methods have been around for so long, it's hard just to put in a new system like CUPS and just expect it to take off right away. So over time CUPS will become more and more popular and the others will become less and less used. And CUPS is already the default in Fedora Core 5. Now Linux uses print queues. So just like in England they say queue up, that means line up. They line up for, whatever, to get on the train or to get on a roller coaster, whatever it may be. You queue up, is the saying. Well, in Linux, you have print queues. So just like in London how queues are lines, print queues are lines of print jobs. So these print jobs line up to be printed on a particular printer. So it's just a line. It's a queue of print jobs to be processed by the printer. Now print jobs are submitted by LPR. That's the name of the program. LPR is how you submit a print job. However, you might use some other program that in turn spawns LPR. So if you're in a graphical program like OpenOffice Writer and you say print, it spawns LPR and actually prints the job. So you don't really see the LPR command running, but it runs. And then at the command line, you can of course just use LPR to print a text file, or you can cat out something, grep it, and you can then pipe it to LPR and send it to the printer. Now jobs in queue are copied and sent to one of the two directories below to be printed. And this is based on what printing system you're using. So if you're using LPD, those jobs go to var spool LPD. If you're using CUPS, those jobs go to var spool CUPS. Now LPD is what monitors the queues for jobs and prints them. Linux accepts remote print jobs so it can function as a network print server. So you can run Linux as a print server for all your printers. If you wanted to have other operating systems submit their jobs to your Linux server and have those printed out to the printers, you can do that. Or Linux can send print jobs to other print servers. So you can configure Linux to send your print job to a Windows print server and print it, through a Windows printer. So there's a lot of different ways to use Linux printing. It's very flexible and it's very network oriented. Now one benefit to the new CUPS system is that it can query printers to find out about their capabilities. So in Windows we're used to this working, through drivers. Your print driver in Windows can tell what type of printer you have, how many trays it has, how much RAM it has. It can even tell if it's running low on paper, all those sorts of things. When the toner cartridge is about to go out, it can tell. In Linux, we're not used to that with the old LPD BSD print system. But with CUPS, this is a capability that CUPS can take care of for you. Now PostScript is a printer language. It's the standard used to send Linux printing output to printers. And PostScript, of course, is also used by Windows. You can get Windows PostScript print drivers for PostScript printers. So the printers have to be PostScript compatible. And those are the best type of printers to use for Linux because Linux supports PostScript just right out of the box. But Linux can also print to printers that don't support PostScript. So GhostScript is the PostScript translator. It takes the PostScript output and turns it into large bitmap files that can be printed on most any printer. So the negative side to this is that these bitmaps files are large. So you might have an 80K PostScript print file and it could turn into 4 megs by the time it's printed and it goes through GhostScript. So if you had a PostScript printer, you wouldn't have that type of problem. But the important thing is that GhostScript still works for those little, HP or Lexmark print inkjet printers, and the smaller laser printers. A lot of the printers now that don't support PostScript. So Linux print drivers are part of GhostScript. Info on GhostScript can be found at this website here. Now the etc printcap file is the main config file for the BSD and LPR-NG print systems, but CUPS doesn't use this file. CUPS uses various config files that are found in /etc/CUPS. You can add printers by editing the etc CUPS printers.conf file, but the easiest way is to use the web-based interface located on your local host web browser at port 631. So this is actually a standalone web server that runs just for configuring CUPS, and it's on port 631. And we'll go and we'll look at how to configure that and use it here in just a little bit. Now printing command line programs are listed here. There's LPR, that's to print a job. There's LPQ, that's to show print queue information. And there's LPRM, that's to remove a job. At the Big Sky Fishing Supply Company, let's add a printer, test sending print jobs, and apply printer queue permissions. So let's go over to our Linux server, and I'm already logged in as root. The first thing I'm going to do is create a printer. So the best way to create a printer is through the CUPS web interface. Now you can create a printer if you go to System, Administration, and Printing right here. Let me show you this interface here real fast, and then we'll go to the best interface, which is the CUPS web browsing interface. So this is the Red Hat Fedora printer configuration utility, and here I can add a new printer. If you scroll through here, let's just get to the point of almost adding a printer and then we'll stop. But it's a lot like Windows, so you have a name of the print queue. This will be the print queue that you want to name it. Here's a description. You'll have to select whether or not this is a locally connected device, a CUPS IP printing network device, Unix LPD, Windows SMB, so you can print to Windows printers, Novell, or networked JetDirect HP printer. That's what that is. This is a networked HP printer. So if I just leave it as locally connected, it knows dev LP0, that's actually the parallel port on the back of this server. Well, in the case of this virtual server, it would be the parallel port on the system that it's attached to. But on the back of your Linux server, here's dev LP0. It's going to be the same device. It's going to be the same parallel port on the back of your server. So if I click forward, here it's just like Windows, where you have to select a brand name, say HP, and then you have to select a printer type. You may need to go out and see if you can download the drivers for the particular printer if it's not shown here. Okay, so let's select a LaserJet 4100. I'll say forward. And it says you're about to create this device, dev LP0 HP LaserJet local print device. I'm going to say cancel, and we'll go and we'll do this over on the CUPS web interface, and you can see what that's like. So let's close this out. I'm going to open Apache, the Unix web browser. I'm going to click in here, the address bar, and the URL is http localhost:631. So this is the CUPS web interface, and here even a regular user can come in and like manage jobs, but to administer the printers and the classes, things like that, you have to be administrator or root, of course. So let's go into do administrative tasks first off, and you have to log in. I'm going to log in as root. Whoop, forgot to type the password. Root, and the password is Big Sky Fishing. Alright, now we can manage classes of printers. This is a way to group printers together. We can manage jobs, the print jobs. Then down here we can manage the printers and add printers. So I'm going to click Add Printer, and it asks for the name of the printer. Let's call it Test Printer. Location, Bozeman, Montana. And this is going to be the Big Sky Fishing Supply Test Printer. We're just going to set up a test printer for the Big Sky Fishing Supply Company right now. So let's say continue. Now it asks us what type of device is this? Is it going to be a parallel port right on the back of the system? Is it going to be a USB printer? Is it going to be an HP Jet Direct, an IPP printer, Internet Printing Protocol that can be accessed through HTTP or IPP? Is it going to be an LPR LPD host or printer out on the network? You can enable LPD printing on print servers, on network interface print servers. So if you have a printer that has a built-in network interface with an Ethernet jack on it, usually you enable LPR LPD printing to those print servers. Now if it's an HP, you might use HP Jet Direct instead. Usually the HPs, though, they handle both. Scroll down here, there's a lot of USB printers, and then there's Windows printer via Samba. So if I have an existing Windows printer that's shared on the network, I can add that as a local printer on this system and print over the network to that Windows shared printer. Very cool thing to do. So let's just say that this is a local parallel port printer. I'm going to leave it there, and we'll say continue. So it asks for the make of the printer. What kind of printer is this? Let's say that this is a HP printer. I'll say continue. And then of course it wants to know what kind of HP printer it is. I'm going to say this is an HP. Here it is, 4100. Just say this is a PostScript 4100 printer. So it has PostScript enabled. I'll say continue. And printer test printer has been added successfully. So if I click on test printer, it shows me the status of my test printer here. It knows what type of printer it is, where it is, the location. It's idle, it's accepting jobs, and it's on parallel port dev LP0. So it's expecting it to be directly connected to the back of the server. So I can choose to print a test page to it. I can stop the printer. If the printer was already stopped, I could start it. I could set it to reject jobs. If it was already rejecting, there would be a button here that said accept jobs. I can modify the printer's description, and I can reconfigure the printer or delete the printer or make this the default printer on the system. So we created a new printer for the Big Sky Fishing Supply Company. Let's go back in, let's go through some of these options up here and just look at what's available. So here's administration again. Here's manage jobs. So right now there's no active jobs. Let's go to a command prompt and let's do a few commands and check out our printer. So if I type lpstat -t, this is like all the different lpstat commands together in one command, and it tells me all the different statuses for different LP or printing features. So it tells me the scheduler is running. The scheduler is cupsd. If I type ps -ef and I grep cups, you can see here, here's the cups.d program. This is actually our print server. Cups is configured by default in Fedora 5. So it tells me the default system destination is this printer, test printer, and the device for test printer is parallel port dev LP0. It's been accepting requests since January 1st, and the printer is idle and enabled. So let's say I want to print something to it. I have two different commands I can use to print something to it. I can use LP, like this, lp/etc/hosts, and I just printed a file to it. So I printed etc hosts to the printer. And I didn't have to specify a printer because this is the default printer on the system. So it gives me a request ID. The other command I can use is lpr, and I'm going to print etc password. And no output there, but it's printing. So let's do lp-stat-t again. And you can see here there's a job in the queue right there. So let's also try lp-stat just by itself. No jobs in the queue. Let's try it again. Okay, no jobs in the queue. So our jobs printed that fast. They already printed. Right off the parallel port on the back of the server. Now, if we disable this print queue or set it to not accept jobs, we can kind of see how the jobs queue up or line up in the queue. So let's go back here. Let's click Show Completed Jobs, and you can see here's the completed jobs that just printed on the printer. And it numbered the jobs, job 2, job 3, and it gave you the name of the file that it printed and the size and the person who submitted it. If I go to show active jobs, there's no active jobs on the printer. So let's go into the printer, and let's say that this printer is going to reject jobs. Okay, it's no longer accepting jobs. So let's go back here and let's try to reprint something. Okay, it tells me it's not able to print the job because the server is not accepting jobs. Alright, it worked. So let's go back here and let's have the printer accept jobs. But let's have the printer stopped. Alright, the printer is paused, it says. So let's try to print again. Okay, it took the print job. So now let's see what's in the queue. It says the printer's paused and the job's in the queue. You can see here. Let's go over and look at the job status, jobs, and there it is. There's our job, pending. So we can cancel the job here. We can hold the job. We can go back to our printer and we can start printing. Test printer has been started. And let's go to jobs. We can see it's processing. Let's click refresh. Processing. And it's gone. We can go to completed jobs. And there we go. Completed. So those are some of the different commands. Let's try one other command before we're done with the different commands here. Let's pause our printer again. Let's resubmit a job. And let's do lp-stat. See the job there. And let's remove that job from the queue with lprm. That's lp remove. So let's look at lprm. Do a man page on it. You can see lprm. You can submit the destination and then the job ID. So we should be able to just do lprm and then the job ID, which is over here, test printer-5. Job or printer not found. Well, let's just try 5 then. There we go. That's all we need to do. So this right here, this is the job ID and this is the printer name. So although it looks like it's combined into one, it's really just the job ID and then the printer name over here. So let's go back and let's continue our queue. Whoops, printers, start printer. Let's go into classes and take a look at classes. Let's try to add a class. And we'll call this test class. The member of this class will be test printer. And test class has successfully been added. So if I click on test class, you can see here by the icon, a class is a group of printers. So a lot of times what you can do with classes is, say you have lots of print jobs, you can have lots of printers and all in one class, and people can submit their jobs to a class, and sort of like a pool, the job load can be spread among those different printers that are all in that class. So with that, let's go back to our slides. So we were able to add a printer, test sending print jobs, and apply print queue permissions. So let's go on to our next slide. Now we're going to talk about remote management in Linux. Linux Plus Objective 2.17 says you should be able to perform remote management, for example using RSH, SSH, RLogin, and VNC. Before we talk about those applications, first let's talk about the original remote management application for Unix. It's called Telnet. Telnet is a remote access command line prompt. Telnet is freely available. It comes in Windows XP both in command line form and in graphical form through Hyperterminal. Of course, Telnet is a text-based command line prompt, so you don't really get graphics out of Telnet, but you can use a graphical program to do it, which is Hyperterminal. Now, the weakness with Telnet is that all data passed is sent in clear text. So if you log in as root over the network and you type in the root password, anyone with a protocol analyzer like Ethereal could get your password, and then they could log into the Unix server as root. Telnetd, by the way, is the Telnet server in Linux, and it can be easily started, and it comes on the Fedora software media. Now, what most people recommend to use instead of Telnet is SSH. SSH stands for Secure Shell, and it's similar to Telnet, but all data that's passed over the network between the SSH client and server is encrypted. So that means someone can't get the root password if you're logging in as root. Now, SSH is installed and enabled by default as the only remote management application in Fedora Linux. So when we installed Fedora, by default SSH was part of that, and then the firewall for Fedora when we installed it was enabled by default, but SSH was allowed through. So SSH is the only installed and enabled remote management application in Fedora Linux. Always keep your firewall in mind when you try to do remote management. If it's not allowed in the firewall, it's never going to work. So for instance, if you go to use VNC or one of these other applications, they're not going to work until you shut down the firewall or you specifically allow those applications in. Now, RSH and RLogin are similar to Telnet, but they can do remote commands between systems without login. So you can configure RSH, for example, to not have a login. You type RSH, the name of the remote server, and then the command, and that command's immediately executed on the remote server. So they're a little dangerous. They're very convenient but dangerous, and they're also not encrypted like SSH is. Now, VNC Server is a remote management application, but it's graphical. It gives you a graphical desktop that's running on the remote server. It's installed by default, but it's not started by default. VNC is the graphical remote console, and it's also not allowed in the firewall by default. So with that, let's check out some of these remote management applications. First off, let's use SSH because that's already enabled and turned on by default. So if I minimize this slide here I have installed a secure shell client called Secure CRT. If I open this up, you can see here I've already configured the connection to the Big Sky Fishing Supply Linux server. If I click on Properties on that, you can see how I configured it. I set it to SSH version 2, which is what's required out of Fedora Linux. I typed in the IP address. You can see it defaulted to port 22. I didn't change that. I typed in root as the username, although they recommend you don't log in as root, log in as a regular user and then SU to root. And then the password is the authentication method. So if I say OK there and I click connect, it tells me the MD5 hash is off. That's okay. I'm just going to say accept for now. It prompts me for the root password. If I type that in, I get a remote prompt on the server. So here I can do ls-l. Any command I could do over on the server console in the GNOME desktop, I can do here. I can start things, I can cancel print jobs, anything I can do on the remote system I can do here remotely through SSH. So you should be able to take your Linux server now and put it in the closet or in the data center and just access it through SSH if you just need command line, or VNC if you need a graphical desktop, and we'll do that in just a second. So now I'm going to log out, I'm going to exit, and we logged off the Linux server using SSH. So next off, let's try out VNC. Okay, to use VNC, I'm going to have to go to the server and configure it first. So let's go over to the Linux server. And the first thing I'm going to have to do is drop the firewall or allow the specific ports for VNC. As we're just demoing this out today, I'm just going to drop the firewall. So to do that, I go to System, Administration, Security Level, and Firewall. This is where you configure the Security Enhanced Linux or the firewall. I click on that. So right now you can see the firewall is enabled and there's no trusted services configured here. We're just going to say let's disable the firewall and say OK there and then yes. So we disabled the firewall. The next thing we need to do is to start VNC. To do that, I'm going to open up a terminal window and I'm going to say VNC server. This will start the VNC server, and notice that it started it at this :1 desktop here. That's important when we connect. We need to know that it started at :1. Now, one command we haven't talked about is apropos. Apropos just means go out and look for all the man pages that meet some text search screen that you specify. So I'm going to type apropos VNC, and it's going to give me every program on the system that has the word VNC in it. So you can see here's the XVNC server, here's the VNC config program, VNC password, and the VNC server program that we just started. That's also what you use to stop VNC server. Now one more thing we need to do is set the VNC password. So I'm going to use this program, VNC PASSWD, and VNC doesn't use the Linux username password system. It just has a password, a single password. So that's one of the limitations of VNC. So for the password, I'm just going to type the root password, Big Sky Fishing. Alright, and we set the password. So now let's go back to our Windows system. And here on the desktop, I've installed the VNC Viewer. The VNC Viewer is available from Real VNC out on the internet. It's free, and besides just the viewer, you can get the Windows server, you can get the Linux server, you can get VNC for just about every operating system available in the world today. You can also get the source, so you could take the source and put it on whatever operating system it's not available for. The VNC server and client in Windows are only about 700K, so it's amazing how small they are. You can actually fit them on a floppy disk. And so you can use the VNC client in Windows to talk to a VNC server in Linux, or you could use the VNC client in Linux and talk to a Windows server. There's even VNC for like Palm Pilot devices and Windows PDA devices. So it's amazing everything you can do with VNC. So with that, let's connect using VNC. So here is the IP address of the server. This is from when I connected one time before. There's the IP address, and then you have to put in this :1 to connect to the first desktop. So if I say OK there, I type in the password. This is the VNC password. This gives me an X Windows desktop on the remote server. So anything I do here is running actually on the remote server. Now it's not GNOME, it's not as easy and friendly, but it is X Windows, it is graphical. So I can do things like start gedit, and I can open a file on the Linux server. I could print that file, I could save it, search, do whatever I want to do. You know, this exact same tools. All these are running on the Linux server. They're not running on my PC. So I could start here, I could start Fedora, you know, the Linux web browser. I could start an email client. I can do whatever I want to do, just like I can do on the command line on the real server. So this is how VNC works. You're looking at whatever is really happening on the remote server, and you're just sending over your keyboard and your mouse input back to the server. So let's close this out. Go back to our slides here. So we're done talking about remote management. We learned about Telnet, how it's unencrypted. We learned about SSH and how it's the preferred method and it's enabled by default. We learned that we should keep in mind remote access going through our firewall and how it has to be allowed through the firewall. We learned about remote shell and remote login, and then the VNC server. So with that, let's move on to our next slide. Now we're going to talk about NIS. NIS is Network Information Service. Linux Plus Objective 2.18 says you should be able to perform NIS-related domain management using YP commands attached to the system to a network directory service such as NIS or LDAP. Now, you don't have to actually be able to use all these commands and really attach it to a network directory and all those complex configurations. Those really are very difficult, very advanced tasks to do all that. In this slide, we're just going to learn what NIS is and what it can do for you. Some of the basic commands give you a good understanding of it, and that's really all you need to know for the Linux Plus exam. Now, NIS is a protocol used to simplify user authentication. But more than that, it's a system, and I compare it to the Windows Active Directory. It provides centralized authentication and a number of other centralized services for multiple Linux servers. And it's interoperable between different types of Linux and Unix. Now there are several kinds of NIS, including NIS, NIS Plus, NIS-YP, and NSS, Name Switch Service. The NIS-YP version, which is where all the commands for NIS came from, can no longer be used because of a trademark issue. YP stood for Yellow Pages, and as you can guess, that might be a trademark issue. NIS is best installed when you install the system, not afterwards. The NIS client is called YP Bind, Yellow Pages Bind, or YP Bind. YP Bind's main configuration file is at etsy/yp.conf. Now it's possible but complex to have a Linux machine authenticate to a Windows Active Directory server. For more information, see this article in Redmond Magazine. The author says he was able to make the Linux system authenticate to a Windows Active Directory server, so you could log in using your Windows Active Directory username password. This is done with Kerberos. Windows uses Kerberos for authentication. So there is a Linux Kerberos client. Now LDAP is the Lightweight Directory Access Protocol, and Windows Active Directory uses a modified version of LDAP for directory lookup. So LDAP is used to look up commonly like email addresses and email groups. It's a centralized directory service. So this slide was just meant to give you a little overview of NIS, just a basic introduction so you know the purpose of NIS and what it can do for you. With that, let's move on to our next slide. Now let's talk about creating and modifying basic shell scripts. Linux Plus Objective 2.19 says, create, modify, and use basic shell scripts. But what are shell scripts? Well, scripts are text files with more than one command in them. So, a shell script could be as simple as a series of commands in a script, and you run that script and it does that series of commands. But usually shell scripts have some sort of logic to them and they make a decision. You can have an if-then statement. You can have a do-while-true statement. You can compare scripts to programs. So scripts are similar to programs. It's its own little language. You sit down, you write them, and you create them to do custom things. Although programs are usually compiled, and they're usually much more complicated and complex than scripts are. Scripts are a little bit more simple, and they use the Unix or Linux tools that are already available. So, usually scripts on Linux use the features of the shell that they run in, like bash, or corn shell, or C shell. Those shells, if you type man on the bash shell, it's many pages long, and there's many features in that shell built in for scripting. And then, of course, there's the Linux tools, some of which we've already learned about, like awk, sed, grep, and so on and so forth. So really the only way to learn scripting is to practice it and write scripts. The more you move into being a Linux system administrator, the more you'll be required to be able to write shell scripts. And that's usually because time, right? I mean, it's easy to modify one user, but if someone walks in and says, we need to modify all 3,000 users, well, gee, that could take a long time. You know, maybe I should write a shell script to do that, to help automate that task for me. And then I could spawn that shell script to run at midnight over the weekend and modify all the users while I'm at home asleep in bed, right? Now, even in Windows, there's Windows Scripting Host, which is just a shell scripting language called WSH, or Windows Scripting Host. The most compelling reason to write shell scripts, as I said, is to save time. Any script should start with the first line telling the operating system what shell program this script should run in. For instance, this should be the first line of a script that's going to run in the bash shell. So I could be in the bash shell and I could run this shell script, and if it has this at the start of it, the operating system knows, oh yeah, this runs in the bash shell. I'm going to start up a bash shell and run this script. I could also be in the bash shell and I could run a script that's made for the corn shell or the C shell. And it could have this pound bang /bin /ksh here at the start. So your bash shell would start a corn shell or KSH, run the script, and give you the results. Now for more information, read the bash man page and see the advanced bash scripting guide at this link. This scripting guide is very extensive and has lots and lots of examples, and it's very high quality if you're interested in learning about bash shell scripting. So with that, let's write a script. We're going to go over here to the Linux server. Now, as I said, a basic shell script could just be a series of commands. So let's write a basic shell script. I'm going to use VI, our favorite text editor, and we're going to call this basic-script. Alright, I want this to run in the bash shell, so I'm going to insert right here. I'm going to hit I, and I'm going to say pound bang /bin /bash to tell it that this is going to run in the bash shell. Now I'm just going to do a series of commands. Let's say I want to cd to etc. I want a cat etc password. I want to print etc host. and I want to do a PS. So this is a basic shell script right here. I'm just doing a series of commands. Most shell scripts are much more complicated, and we're going to learn about those in just a second. But this is a basic shell script. That's hard to say. So let's try it out. I'm going to do colon right here to get down to the command prompt. Do right quit to quit out. And we save that basic script program. I'm going to do ls-l. And here it is right here. Basic script. Now notice the permissions over here. To run a script, it has to be executable. So to run this script, I'm going to have to change it to be executable. So I'm going to do change mod 744 basic script. So the 7 added executable to the basic script. So if I do ls-l basic script, I can see now I have the executable and the color has changed on the basic script. So now let's execute the basic script. I have to tell it what directory it's in because my home directory isn't in my search path. So I'm going to do basic-script and let's run it. Alright, so it did a bunch of stuff. Let's see what it did. First off, it catted Etsy password here, and then it showed the PS. So we didn't see everything that it did, but I bet it did those other things too. Let's cat basic-script and see what it was supposed to do. So it changed to Etsy, it catted Etsy password, it printed Etsy host, which we didn't see. We didn't see the CD and we didn't see the printing, but we saw the PS. So it's pretty safe to assume that it did all those things. So our basic shell script appears to have worked. So now let's look at a little more advanced shell script. I've written a little bit more advanced shell script, and it's called usernum. You can see it right here. I've already written it. I've added executable permissions to it. And so let's take a look at it. Let's cat out usernum. Okay, this is the shell script. It's not much more advanced. It's a little bit more advanced. So what it does is it cats Etsy password. It redirects that output to awk, and it says print $1. Now $1, if you remember from a previous video, is the first column of Etsy password, which is the usernames. It sends that to a file called users1, which is right here. So it's going to put all the usernames in that file. Next, it cats out that file. It pipes it to word count. So word count is going to tell you 3 different things. The first one being the number of lines, and that's what we're interested in. So again, I use awk, and I print out, I capture the first output from the word count program, which is the number of lines, which would also be the number of users. Then I send that to another text file called users2. Then I echo, there are currently X number of users configured on this server. So what this does right here, these little back quotes here, this runs another program and it cats users2. So it fills in the blank from whatever user count it got when it ran the word count. So it's a little bit more advanced, and I mean, like, the purpose of this script is that you could run it whenever you want. So I can run usernum whenever I feel like it, and it would tell me how many users are configured on the server, instead of me having to type this every time I want to know. Right? So let's run usernum. So it just prints out, there are currently 40 users configured on this server. That was quick and easy, right? I can save that in my home directory and I can run it anytime I feel like it. In fact, later we'll talk about scheduling, and I could even schedule this to run every morning at 8 a.m. and have it emailed to me. So just an example of an automated task that you could perform with scripting. So we learned about scripting. Now let's move on to the last slide in our video, and that's the conclusion. So in conclusion, we learned how to manage and configure print jobs and print queues. We learned how Linux has two different printing systems, BSD and CUPS, and how CUPS is the standard printing system that's installed with Fedora Core 5. So that's what you should be most familiar with. There's a number of different commands as they relate to printing. To print jobs, we learned about LPR and LP. To see the status of print queues, we learned about LPstat. To cancel print jobs, we learned about LPRM. And then we learned about the CUPS web-based interface, which is at localhost 631. So you can just put that in your web browser. You can put that in Fedora and go to the CUPS web-based interface. It's an excellent, excellent web-based interface. We learned about remote management using Telnet, SSH, and VNC, and we saw how those worked. We learned the basics of NIS and YP commands, and how NIS is a centralized authentication system for Unix. We learned how to create and modify basic shell scripts, and how much time shell scripts can save you through automation and just automating repetitive tasks. So with that, that's the end of video number 8, Administering Linux Part 2. I hope you learned a lot, and I look forward to the next video. Thank you.